Good evening, everyone. In this video, I will continue the discussion with steps for implementation modeling. I will specifically focus at realizing associations. So, associations are the glue of the class model. We have actually been seeing, okay, so they are primarily used, okay, so they provide these access paths between objects. Okay, so several classes are actually associated, okay, so and then like they provide the access path for between different objects. We have seen these things in the earlier videos. Okay, then okay, so the models are ready. Okay, so from the design, like the models are polished and everything is ready. Now you are actually trying to implement. So that means like we need to formulate a strategy for implementing these associations. So either we can choose a global strategy for implementing all the associations uniformly. That means like all the associations in the class model, you are actually using the same approach. Okay. Alternatively, you can select a particular technique for each and every association. What are these techniques? We will talk in the coming slides. Okay. But of course, like whenever we are actually trying to implement these things, we definitely have to take into account this the way the application will actually use them. Okay. So that is the one based on which like you actually try to find a particular technique for that particular association or for the complete group of associations. Okay. So first what we have to do is like we have to basically analyze this sort of association traverse elements. Okay. So let us look at that one. Associations are by inherently bidirectional. Okay. However, if the application has some associations that are traversed in one direction, okay, then their implementation can be very simple. Okay. So basically the point is like usually the associations are bidirectional, so it can come in any of the direction. But then like if it is only one direct association, okay, if the traversal is only in one direction, then the implementation is actually easy. We will see that in the next slide. But the problem is like if you implement it like that one in future, like say for example, the requirements may actually change. We may need to add a new operation that actually basically comes back from the other one. Say for example, class A is associated with class B, okay? And if you think like only one directional association, and if you implement it like that one, in future, like if there are requirements changed, then like somehow you have to come back to object A, okay? That is class A from so if you have to come in the reverse direction, then it would make our lives difficult. So it should be actually planned for it. Okay, so better that most often, like whenever we are trying to develop prototypes, okay, we need to use these bidirectional associations. Okay, then if we can add any new behavior or like if we modify anything in the application, okay, application model or something like that, okay, then it would be very easy. Okay, so changing the application is relatively easy. Okay, and it can be done quickly. So now let us look at one-way associations. If an association is traversed only in one direction, that is one-way association, then we can actually easily implement it with a pointer. Okay, the pointer is something like an attribute, okay, that contains an object reference. Say for example, if your class model is something like this one, there is a person, okay, who actually works for a company. And if you want to implement it as a pointer, in the person, you will have this sort of employer as the attribute, which will have the pointer to that particular company. See, you are actually putting an attribute here, okay, with that reference. So the employer is now being added, okay, as the attribute with the pointer reference, okay, which is pointing to the company. Okay. The actual implementation of this sort of pointers can be, say, for example, in certain languages, like it can be a program language pointer, okay, or it can be a program language reference, say, for example, in terms of Java is concerned, okay, or it can even be a database foreign key as well, okay. So we are not that much worried about the real language level implementation, okay. There can be several ways, but then like conceptually, if you can design a pointer which is actually pointing to that particular the second object, then it is efficient. So if it is one way association, it is pretty easy. You can have this sort of point. If the multiplicity is one, then it will be a simple pointer. But if the multiplicity is many, okay. So if assume like from the other way around, so company Okay, several persons are working for the company. Okay, not works for, say for example, now this association is employees. Okay, then basically like in the company, you will actually maintain a set of pointers which is actually pointing to multiple persons. If the multiplicity is many, then it is a set of pointers. Okay, that's what I was talking about. That's about one-way associations. But if you have two-way associations, which is actually the norm, okay, and many associations are traversal in both directions. But the issue is like these traversals will not be with the same frequency. That is something which we should remember. Okay. So in one direction, like the traversal may be more, and then in the other direction, the traversals may not be that much that frequent. Okay. So there can be several approaches. There are actually three approaches to their implementation. The first implementation is implement it as a one way. Implement as a pointer in one direction only, and perform a search when backward traversal is required, because the pointer is basically going from say for example from class A to class B. Okay, if a backward traversal actually has to happen, then you can basically come back with the pointer, but it will be a little bit expensive procedure, because the searching backward is actually an expensive procedure. You will be using it when the backward traversals are rare. Okay, so this is about implementing the two-way association, implementing it using one-way association. Then if you want to implement this two-way, okay, you can actually implement it in two-way. Okay, with you can have two pointers, okay, in both directions. This actually permits this approach actually permits fast access. Say for example, think about this one, the same problem, the person and the company. So the person is the actually the employer. As an employer attribute, it is actually storing the company detail, company object as the reference. Okay, so you have a pointer here. Now in the company, there are several employees. Okay, so what you can do is like you can actually have a set. Okay, set of object. Okay, so basically with all these references, with these pointers, the pointers can actually point to that particular person. Okay, so that's how like you can actually implement this sort of two-way uh, uh, this two-way association. Okay, so but the issue with this one is like if either direction is updated, either the company is updated or the person is updated, then the other must also has to be updated to keep it the link consistent. Okay, you need to have this sort of pointers and the links to be consistent, so you need to maintain that one. This approach is actually useful if accesses outnumber updates. If you have to update the thing, then you are updating the pointers as well. This will be a complex task again. But then, like if you are primarily worried about accessing, then this way of two-way implementation is excellent actually for the associations. So there is also a third way possible. Okay, for implementing this bidirectional association. Okay, so you can actually implement with an association object. This is the actually the association object. An association object is a set of pairs of associated objects stored, okay, associated objects stored in a single variable size objects. So basically the point is like this is the association object. Okay, so basically these are the association object. It is a set of pairs of associated objects. Each object here is actually a single variable. It has a pointer to that particular person. Now the point is like say for example you have this associated object. These two pairs of these objects with two pointers will actually say like there is a association between person and the company. So this is how like you can actually implement it. Okay. For efficiency sake, like we can implement an associated object with the two dictionary objects. So dictionaries are also like key value pairs, the way like we have seen maps in Java's implementation. Java also has dictionaries, so you can actually use for key value pair storage. Okay, so basically in this way, like one object is actually used for the forward direction, another object is actually used for the backward direction. So there is associated object with two dictionary objects like this one. Good. The good thing about this approach is the association object does not add any attributes to the original classes. Okay, so this is the very good thing about this one. So then, like say for example, it would be very useful for extending predefined classes from a library that actually cannot be modified. Say for example, if you look at the other two approaches, to put a pointer, like you have to take that class and then like you have to basically modify it. So I am putting this pointer. If you really look back, okay, so earlier like this reference was not existing, so now I have to take the class and then like I have to basically put this one, okay, to basically realize that association, to implement that one. Whereas in this case, like if you really see, like I'm not modifying either the person class nor the company class. All the references, all the pointers are actually existing in an outside object. So this is very good in case like you get the classes from a library and you cannot modify them. Okay, so these are the three approaches to basically implement these sort of bidirectional associations. One is like using a single one-way association, another one is with two-way association with this triangular we have seen, the pointers, or with this sort of association object. Of course, that's about the basic associations are concerned. But then like we have discussed about several advanced associations when we were talking about this sort of class models, okay, in unit 1. The association technique, okay, so the appropriate technique using which like you actually implement that particular association actually varies a lot. Suppose if it is an association class, okay, so the association has an association class. The usual approach is to promote that the association to that class. This way, like you can actually handle all the attributes, whatever that association has, and if that association class itself has other associations, okay, even those things are also taken care. If you promote this association class to a class, okay, association itself to a regular class. Alternatively, if the association is one to one, okay, with the class, okay, and there are no further associations, okay, for this association class, then it would be like you can actually implement the association with pointers, okay, and store any attributes from this association class as attributes in one of the either class on both sides. Say for example, class A is there, class B is there, and they are associated, and then like there is an association class C. So if you basically implement with these pointers, okay, and you basically can take all its attributes and put it in one of the things, one of these two classes, class A or class B. But the problem comes is like one, if it is not one to one, but if it is one to many, okay, you actually put again you will implement with pointers, but you actually store all the attributes for this association class as attributes of the many class, one to many, then you will put it in the many class. In fact, actually, we have discussed all these things when we were discussing about associations in the class model. Okay, so you can go back and check those videos. Okay, so that will discuss in detail. Okay, now the associations can be ordered associations. We have also discussed them. Okay, so if it is ordered association, then we can actually use ordered set of pointers. Okay, for the particular ordered associations. Okay. We also have seen like sequences, okay, sequences for the association as well. Actually, we have seen like sequence, it is an ordered collection of elements with duplicates allowed. We discussed about like when we were discussing about the class models, okay, so we discussed about the travel itinerary and then like you can visit several cities or you can fly over those things. So in that sense like sequences, okay, it can have this sort of ordered collection of elements, but duplicates are actually allowed. Okay, then you can actually use list of pointers. Okay, if it is purely ordered, okay, and then like duplicates are not allowed, then use a set of pointers, okay, in this case. But if it is sequences, then use a list of pointers. But similarly, like we have also seen the bags. Bags are also collection of elements with duplicates allowed, okay, with duplicates allowed. But then like ordering is not so important, okay. Then you can actually use an array of pointers. Okay, so then the other type of advanced associations which we have already discussed, okay, are these qualified associations. If qualified associations, if the multiplicity is 1, okay, implement it as a dictionary object. But if the multiplicity is many, implement it as a dictionary of object sets. Okay, but the multiplicity being many, for qualified associations is extremely rare. Okay. Then what about NRI associations? NRI associations, again, we can actually promote the association to a class. How we promote that as in the regular class? Okay. So we have discussed that in detail in unit 1. Okay. So you go back and check those things. Okay. So in the advanced class concepts. Okay. So then what about the aggregation? We can actually treat the aggregation like a simple ordinary association. Okay, there is no problem with this one. Okay, with the aggregation. So in terms of the implementation, there is not much big difference between an regular association and an aggregation. But composition actually makes the situation a little bit tricky. We can also treat the composition like an ordinary association and then like implement it like the ordinary association. But we have to add this. We need to do some additional programming to enforce the dependency of the path on the assembly. Because like with composition, okay, say for example, if the assembly is destroyed, yeah, that object is destroyed, all the parts should also be killed. Okay, that is the one of the restriction which we have discussed about it when we were talking about aggregations and compositions. So the composition, if you want to implement it, you can actually make it like an association, but then like have this sort of additional enforcement. Okay, when the assembly is actually deleted, all the parts are also automatically deleted because they are directly dependent on it. That's about like not just implementing the regular associations, okay, but also like all these sort of advanced associations, how you can actually implement them. Okay, that's about the implementation. Okay, so implementing associations, especially regarding the reference are concerned, we are still in chapter 17. Okay, object-oriented modeling and design with UML. Okay, Michael Blaha and James Rambo. Thank you very much for your attention.